All right, so as promised, we have a predicting products volume 2. This one we're going to look at single replacement and double replacement. Okay, and again, I'm going to preface this by saying these can get a lot more complicated. There are a lot more exceptions and rules and variations. We're sticking with some that are very simple, okay? When we get some more advanced chemistry, you'll look and seeing if reactions actually happen. But right now, we're just looking at predicting very simple products. We are assuming all of the reactions will happen, okay? So, there are 2 types. In the last video, we looked at the composition, decomposition, and combustion. For single replacement and double replacement, we know we can identify those based on single replacements having a single element plus a compound, yielding a compound in a single element. Double replacement, 2 compounds on both sides, and then there are 2 ions that are switching places. So let's start with a single replacement. So in this one, we have chlorine plus sodium iodide. Now, I'm going to do a little bit of color coding with my Post-it notes because hopefully with some of my visual learners, it'll make it a little bit easier to see who is going to switch with who and who's going to have new partners. So I want you to think about these in terms of ions, right? Because ions are kind of like puzzle pieces. We have our anion, so chlorine. Again, we're ignoring all the subscripts. Chlorine as an ion is going to form a -1 charge. So it's an anion. Sodium, a metal, which is always in the front, it's going to be a +1 charge. So you'll see it's a different color. Iodine also has a -1 charge. It is an anion, so it's the same color as the chlorine. So if you think about who chlorine is going to switch places with, you don't want to switch with somebody who you're not going to fit with as a puzzle piece. So chlorine is going to replace something that is like it. In this case, that would be the iodine. So when I switch these 2 ions, chlorine is going to kick the iodine out, and now chlorine will bond with sodium. But when we write that as products, because we have changed some ions around, we have to recross charges to see what the new formulas of the new compounds would be. This one is pretty straightforward in that because iodine and chlorine have the same charge, it didn't really change the subscripts a whole lot. But Na +1 crisscross with Cl -1 would yield NaCl. Iodine, just by itself as an element, remember iodine is a diatomic molecule, meaning if it is by itself, we need a subscript 2. So these would be my 2 products. So again, cations want to bond with anions. So think about it like a little puzzle. Now let's look at a double replacement. Alright, so here you can see that we have 4 Post-its because we have 2 compounds on the reactant side. When we think about these, again, ignoring subscripts, when we think about them as ions, calcium is in the second group, +2 charge. Chlorine, we've seen it many times, it has a -1 charge. Silver. Silver is an example of one of the transition metals that pretty much has a fixed charge of +1. But even if you didn't know that, you could figure it out based on the fact that we know nitrate has a charge of -1. So when we cross the charge, we see a 1 here. We don't see another number here, which means that Ag was also 1, okay? So again, notice my cations, my metals, are positive. Anions are going to be negative. So again, we want to switch people who are very similar so that they hook up with somebody who is opposite of them. So right now, calcium is bonded to chlorine. But when it changes places with silver, calcium will bond with the other anion. okay? It's not going to bond with Ag. Those puzzle pieces do not fit. Same thing here. These are not going to bond together. They don't fit. We just want for calcium and silver to switch places. Okay, so we have new dance partners. That's it. So we still have yellow, blue. Well, that's not even really blue, but I don't know. Y'all feel me. And a yellow, and then like teal. But because we have new compounds, we have to recross the charges to see what new products are going to form. So we have +1 and -1. They cancel out. So this product, AgCl. For this one, right here, we got to be careful, protect the poly parentheses. This 1 comes down, we don't have to write a 1. This 2 is going to come outside of the NO3. So we have CaNO3 with a 2 on the outside. Sorry, that's small. I did not estimate that spacing very well. Okay, so these would be my 2 products. So now you can pause the video and try these. When we come back, obviously we will have them solved for you. Okay, so for this one, let's just go ahead and identify what types of reactions they are. This first one, single replacement. This one, double replacement. So let's start with solving the single replacement. So here, I don't have post-it notes. Again, the idea is to hopefully you start seeing patterns. I do want to point out here, hydrogen. Hydrogen is not a metal, but it is operating as a cation here. So it's operating as a positive. So when we look at who will switch with who, zinc is by itself. Zinc's a cation, it's a positive metal. It wants to bond with this anion, chlorine. So when we split them up, these are all my ions. Also note, zinc is another example of a transition metal that pretty much always have +2 charge, fixed charge. But who is going to switch with who? Zinc will take hydrogen's spot. When these two switch places, you will see hydrogen by itself plus Zn +2, chlorine -1. Only thing we need to go back and add, hydrogen's a diatomic. It's by itself here. It needs a subscript 2. So we're done with that one. Now down here at the bottom with a double replacement. So this one, we have polys in both the first and the second reactant. So let's go ahead and split them up. So lead here, if we do a reverse crisscross, this 2 right here is going to be lead's charge. Nitrate, we know, has NO3, and it has that -1. On this side, potassium, +1 charge. This right here is a diatomic chromate. Chromate has a 2 charge, but also you should just memorize it. So CrO4, that entire molecule has a -2 charge. So again, look at the charges, see who's similar, see who's probably going to switch places. They are going to switch places. Lead is not going to hook up with this potassium. They don't fit together. Lead wants to hook up here with the chromate. Potassium will then come over, and its new partner will be nitrate. So when we recross the charges, okay, so we have potassium +1, NO3 -1. These charges cancel out, leaving us with KNO3. Then around this side we have Pb +2, CrO4 -2. Conveniently, these charges are also going to cancel. Pb, CrO4. And you're done.